Alright guys, quick video on absolute value equations and inequalities. Just want to give you a couple examples that you can refer to and go through the process of using the definition while we solve these things. So before we get to that, I want to just review a couple things. Number one, the definition of absolute value. So the definition of absolute value is if I take the absolute value of something, in this particular case it's A. We have two different cases. The first case is we use the positive version of what's on the inside here when it's greater than or equal to 0, and we use the negative version when that thing is less than 0. So this is the formal definition that we want to make sure that that we know. Okay. Other thing is just the process that we're going to go through, and I'll go through a couple examples here so that you can get an idea of how that process plays out. But I just want to make sure that we go over what the process is for solving these particular things, these absolute value inequalities and equations. So number one is always isolate the absolute value. So we always isolate the absolute value before we do anything in order to solve these things. Number two is find the vertex, because the vertex is going to tell us where our two cases come from. When we go to the right of the vertex and to the left of the vertex. And the last thing is really to use that vertex and that's the definition part. Let's use the definition part to split this thing into two statements. Okay, so this is our process. Always isolate the absolute value first, then find the vertex, and then use the vertex to split it into two statements, and we can solve from there. So let's take a look at a quick example. And on this example, we want to sketch a graph and solve it, and we want to make sure that we use the definition. So first things first, we always isolate the absolute value. This is the absolute value, so we want to get that thing by itself, which means I need to subtract 5. So I get 5 times the absolute value of 3x plus 1 is greater than or equal to 5. And then I'll divide both sides by 5. And now I've got my absolute value isolated. So that's greater than or equal to 1. So a couple things here. We've isolated the absolute value. This is the point where we're going to go sketch a graph as well. So let's go over here. Let's look at our coordinate axes here. And what I've essentially done is taken this graph and by simplifying all this stuff, I've kind of shifted this graph around so that the vertex is sitting on this axis somewhere. Okay, so where is this vertex sitting on the axis? Well, we've got to go find the vertex in order to figure that out. So the way that I do that is I say that whatever's on the inside of the absolute value, I'm going to set that equal to 0. So this is to find the vertex. So to find where this thing is or the axis of symmetry, I should say. So go through and solve for x. That'll give us the x coordinate of the vertex, or in other words, the axis of symmetry. So x is going to be equal to negative 1/3. So if I go up here on the graph, I find negative 1/3. I know that this is an absolute value function, so it looks like a v. So this thing generally is going to look something like this. That should be a straight line, not a great straight line, but you get the picture. Okay, so I've graphed this. I can now label my vertex. I know that's at negative 1/3, 0. We always use coordinates to identify where that vertex is. And the other thing that I can label here is I've got a y-intercept. So if I want to find the y-intercept for this particular thing, we're going to come back over here to this function, because this is the function that we've graphed over here, 3x, absolute value of 3x plus 1. And we're going to say, if I've got this function and I want to find the y-intercept, that means that my x value is going to be 0. So how do I deal with this? Well, I just plug in 0 for x. So we plug in 0 for x, and when we do that, we get 3 times 0 plus 1. That means my y is going to this thing's going to be at a height of 1. And my intercept, then my y-intercept, is going to be at 0, 1. Again, always use a coordinate. Okay, so we've got the vertex, we've got this thing isolated, we've got a quick sketch of what this thing's going to look like. And the last thing that we need to do is figure out when does this function, this absolute value function, have a height of 1. So let's go through the algebra just to show you how to do this. So the next thing I'm going to do is I'm going to use this vertex to define a couple different scenarios. So this function is going to have a height of 1 at a couple different places, and I can sketch this over on the graph. We know that this is a height of 1 right here. So this x value, I better get an answer of 0 out of this because we already know that this y-intercept is going to be one of the values that I come up with. So what we're going to do is we need to go through the algebra in order to find this. So the algebra says basically I've got two cases, and these two cases are based on the definition of the absolute value. So my first case is if I go to the vertex and I look to the right of the vertex, so over here, the right of the vertex, that means I'm looking at when my x value is greater than or equal to -1/3, or in other words, to the right of the vertex. And when that happens, I use the positive version of this function. So 3x plus 1, here's this function, is greater than or equal to 1. And I can go through and solve that. The other case, though, is when we look to the left of the vertex. So the left of the vertex, how do I say that mathematically or in symbols? We say when x is less than -1/3. Or again, in other words, when I look to the left of the vertex, this thing has a negative slope, and that's why we actually negate the function. So 3x plus 1 is the opposite of that particular thing, and we want to know when that has values that are greater than or equal to 1. Okay, so let's go through and solve algebraically. Solve for x here. We've got 3x. This is going to be -1. That's going to be greater than or equal to 0. So x is greater than or equal to 0. There's one of our solutions here, or one of our intervals. The other one, I'm going to go through and we need to make sure that we distribute this negative to both terms. So -3x minus 1 is greater than or equal to 1. -3x greater than or equal to 2. X is going to be, I'm going to divide by a -3 here, so that flips my sign. So x is less than or equal to -2/3 is where my other interval is going to come up. Okay. The last thing is going to use this rule, and maybe I should write this on the general rules page. The last kind of rule that we use is anytime we have a less than, that's an and. So our answer should look like a compound inequality. Anytime we have a greater or greater than or equal to, this is going to be an or. Okay, so let's go up here and see what we have. Once we simplified, and this is the point where we figure out, is it less than or is it greater? This one happens to be greater, so this means that my values are going to be going away from each other. So I have an or here. I'm going to write my solution as an or, so x has to be greater or equal to 0, or x must be less than or equal to -2/3, and I'm done. So there are the intervals where this particular function is going to have a height of 1 or greater. All right, so let's check out a second example. I'm going to go a little faster on the second example here. So first things first, we always isolate the absolute value. So there's our absolute value. So I need to subtract 20. And when I do that, I'll get a -20 over here. And then I need to divide by that -4. So I'm going to have -4 times the absolute value, 2x plus 7, is greater than or equal to -20. And then divide by that -4. I get absolute value of 2x plus 7. Flip my sign because I divided by a negative, so that becomes less than or equal to. A negative divided by a negative is a positive, and 20 divided by 4 is 5. So I've got this thing simplified here. I've isolated my absolute value, and that means I can go in and find my vertex. So my vertex, I take what's on the inside of the absolute value, 2x plus 7, set that equal to 0, and then go through and solve for x. So x is equal to -7/2. There's my vertex at -7/2. So I can go over here, I can say, hey, 1, 2, 3.5. My vertex is -7/2, comma 0. And I know this thing is an absolute value, so it looks something like a V. So it's going to look something like that. And the last thing left to do is I want to make sure that I label this point of intersection here, this y-intercept. So in order to find the y-intercept, again, we're going to take this function. This is the function that we just graphed, 2x plus 7. So y equals the absolute value of 2x plus 7. And I want to find the y-intercept, so I plug in 0 for x. When I do that, it simplifies to y equals the absolute value of 7, or just y equals 7. So this point is 0, comma 7. All right, I've got all the preliminaries done. I've got my absolute value isolated. I figured out what the vertex was. Went over here, drew a quick rough sketch. So now let's go ahead and use the definition in order to solve this thing. So the definition, again, is based on this guy right here, this vertex. And it says when I look to the right of the vertex, or in other words, when x is greater than or equal to -7/2, I use the positive version of this guy. So the positive version of whatever's on the inside. And my other case is when I look to the left of the vertex. In other words, when x is less than -7/2. That's my other case, and in that case I use the negative version of whatever's on the inside. So I get -2x plus 7. That's less than or equal to 5. And then we can go through and solve algebraically here. So let's go ahead and do that. -7. 5 minus 7 is going to give me a -2, so 2x less than or equal to -2. And then x is less than or equal to -1. There's one of my possibilities. My other possibility is going to be -2x minus 7. Make sure that you distribute that negative to both. That's less than or equal to 5, so I get a -2x is less than or equal to 5 plus 7 on both sides is going to be 12. And then I got to divide by a negative here, so I get x is greater than or equal to -6. So here are my two possibilities. These are the two intervals. And if I look back up here, this is, remember our rule, less than tells me it's got to be a compound inequality, or it's an and, where the two intervals are kind of running into each other. Greater is when the two intervals are going away from each other. So let's check out what we have. This is the point where you're going to decide that, because we isolated the absolute value here. So this tells me less than, so less than. That means I better have a compound inequality for my answer here. So combining these two and writing these as a compound inequality, I'm going to take the smaller number, put it on the left, so -6. That's less than or equal to x, which is less than or equal to -1, and there are my solutions.